Hello friends, today we are going to cover Module 2 of DP900. Module 2 is Explore Relational Data in Azure. So in this module, we have two parts. We will cover first part only. So in first part, we have we need to explore fundamental relational data concepts, understand relational data, understand normalization, then SQL, explore SQL, wherein we will see what all tools we have to write the SQL. Then describe database objects, wherein we will cover views, stored procedure, or other different database objects. So mainly in this session we will cover only part 1, and in next session we'll cover part 2. So what is relational data? So first of all we need to understand relational data. So we know that everything in the real world, whatever it is, it's in the form of data. Right. For example, if let's take one example of school, right? So in school we have different students, different classes, different teachers, right? So we need to maintain that data, how many students are in which class and which teacher is teaching them. So this way we can have data in the form of name or class, school, and all the details we keep in the form of table, right? So if we see what is exactly relational database, so every data, it is in the form of entity. So entity can be anything, any kind of information which we are recording, right? So if we say entity can be object, entity can be any information, entity can be any events, right? Or we may take example of like customer, product, orders, line item kind of data, wherein if we see these all are nothing but entities only. So we model collection of entities in the form of tables. Table is nothing but collection of rows and columns wherein we are keeping information, right? So each row, for example, this customer table, each row in the customer table contains the data of single customer. Each row in the product table defines the single product. Each row in the order table represents order made by the customer. Each row in the line item represents a product that was included in an order. So this way, in this scenario, every record, every information, every row we can say is single instance of an entity. So now if you see in customer table, we have ID, first name, middle name, last name, email, address, city. These are columns and these are rows. Every row is having some ID for uniqueness. Similarly, in product table, we have different columns: ID, name, price. And if you see that every product is in different row, hammer, screwdriver. So these are different rows. And order table, order number, order date, customer, these are columns and these are rows. Similarly, line item, sorry, these are the columns and these are row numbers. So if you see, each column stores data of specific data type. For example, ID is number type, first name is string type, middle name is string type. So this way every column is having data type of specific data type, right? So if you see that uh, email is in different form. This is text data, right? And it can be fixed, it can be variable, anything can be there. So if you want to see like basics of SQL Server, so we have a lecture series on SQL Server. Basics are covered there. So I will add details of those sessions in description. So if you see that similarly, we can say that available data types that you can use when defining a table depend on the database system as well, right? Like if you are using SQL Server, so it would be different. If you are using some other database, Oracle or some other database, it may be different. So variable types may be different. So there are specific variable types in as per the different tools, and accordingly we use them while declaring the columns in table, right? Okay, next coming to normalization. So if we understand normalization term is used by data professionals. So through normalization we can design the schema wherein minimizes data duplication and data integrity is enforced. Now what is this? So let's go into detail. So in simple form, if we see like let's go back to previous slide. So if suppose we dump all this data in one table, right? Suppose in one table we have all these columns and we are just dumping data. So in that case, what will happen? So for example, if Joe customer is ordering, suppose, multiple products, right? He is ordering hammer, screwdriver, wrench. So it would be duplicacy of data. Like for example, corresponding to Joe, you have to write three records, right? So it would be more duplicacy. Similarly, for Samir, if suppose he is also ordering same three products, so again three lines for that. So if you see, it would be difficult to filter, difficult to process, because it would be, we are just dumping data into one table. And if suppose it would be huge database, right, it's having about 100 to 200 tables. In that case, if you are storing everything in one table, so it would be huge table and complex table, difficult to understand, difficult to extract data, right? And definitely it would be taking time in processing as well. So to avoid everything, we just want to make it normalized. Normalized means in better organized way, wherein data duplication is not there. Every table, whatever is the purpose, will keep separate data, and it would be having linking with the other tables, right? So this is overall normalization, is how to separate the different types of tables and maintain that integrity between the tables and remove all duplications of data, right? So now how to do that, let's look into that. In simple form, if I explain normalization, each entity need to separate into own table, each attribute like into its own column, each district attribute into its own column, right? And then third point is uniquely identify each row using a primary key. Primary key is used to identify, primary key is for the uniqueness, right? For example, here ID 1, 2, 3, 4. This is kind of primary key, right? Two persons cannot have same ID. So this would be helpful to extract the right data. Similarly, for example, roll numbers, right? If you see roll numbers in school, it cannot be same for two students, right? Same way. So these are kind of the for uniqueness perspective. Using foreign key is to link data between two tables. Like for example, if I see that this suppose this customer, Joe David, right? So this is the table for customer, right? Now if I want to see that what all orders this customer has given, so 1,000 number order is ordered by customer 1. It means Joe has ordered 1,000 number order. 1,000 number order, if you see, this is for product ID 1, 2, 3, and one quantity has been taken. It means Joe has taken hammer, only one quantity, right? So this way, if you see, each and every table is having meaningful data related to its own entity, its own right, details, and then we can link the data. This linking in between the tables is required. We can link the data and then extract the required data, and that is also helpful to have the simpler form of tables. Okay, so now moving to next slide. This is to understand what are the different principles of normalization and how do we do that. To understand the core principles of normalization, suppose let's take example of sales data. So in this data, if you can see that a company use this data to track its sales. So here for order number 1,000, it's having customer name Joe Jones, who has taken product hammer 1 quantity. Same customer has taken another product screwdriver 2 quantity. Right? So if you see that with one customer, it's having two products and two times entries are coming in this table. Right? So if you move ahead, so we can split this table into normalized form, right? So because in previous table, what was the problem? That the customer and product details are duplicated. Similarly, if suppose one customer is taking suppose 10 products, so this for this customer 10 times we would be having records in the table, right? So customer name, then other things are in repetition. So what we can do, let's look into how we can normalize it and what all changes would be there. So if we look into this table, now this table is showing that one table is only for customer, one table is only for products, one table is only for orders, and other is for only line item. And this connection is showing relationship between the tables. For example, this id is the primary key here, and it's having relationship with the orders table with id. So here id is primary key, and in order table it's foreign key. Similarly, with order, line item is having relationship because line item is also having order number, right? It's having details of order number and but all products are there. So this line item is connected with order table as well as with product table. So this way we are making relationship between the tables and also avoiding redundancy of the data. So this way redundancy is not there. Customer table is having customer data, product table is having product data. So each and every entity is having data with respect to that particular entity, right? So in every own table, such same type of information this is storing. So if we see that in overall in this overall exercise, what we did, we have decomposed attributes, right, into individual columns and ensure that data is not repeated. So so this example is pretty much hope this is clear, and also this is showing relationship between the tables as well, and which is covered in rdbms, right? So instances, whether it's primary key or foreign key, are there. Primary key is in the master table and foreign key is to create the relationship with the parent table, right? So this way we have maintained this, and this is example of typical relationship database management system which enforce referential integrity. This is referential integrated because why? Because if suppose I want to remove customer data, I cannot remove till the time or all line items are removed, then all orders are removed, then only customer details can be removed. So this way integrity is maintained. We cannot remove master data, right? And similarly, if we see that primary key table can be removed only if all related tables data removed, right? Now coming to explore SQL. So this is very basic of SQL. SQL is structured query language, and this is used to communicate with relational database. This is standard language for relational database. So SQL are statements wherein we are using select, insert, update, delete, create, or drop commands. This is used to work with tables, right? Suppose we need to insert data into the table, then we can use insert command. Select is to retrieve the data. Update is to update is to update specific column value, right? Similarly, delete is to delete the record. Create is to create the table. So these all commands or statements are used in SQL Server. These are SQL statements, and these SQL statements are used to perform tasks like updating data, retrieving data, deleting data, such type of tasks. And some common RDBMS are like which uses SQL, like Microsoft SQL Server, Oracle, MariaDB, PostgreSQL, MySQL. So based on different tools or different databases, our commands or syntax can change, but overall all are structured query language, right? So some if we see that some popular dialects of SQL, Transact SQL, wherein we are using T-SQL in SQL Server, Microsoft SQL Server, and Azure SQL services. Then there is PG-SQL, which is used in PostgreSQL, PL-SQL, which is used by Oracle, and also PL-SQL is used in SQL Server as well. So these are the popular dialects of SQL. So in DP900, we have only basics of these things, not in advance. And for basic, if you need more details, you can go through our lecture series of basics of SQL Server, where we have covered each and every type of commands with examples. Now coming to SQL statement types. So SQL statements are grouped into three parts: data definition language, that is DDL, data control language, that is DCL, data manipulation language, which is DML. So DDL statements wherein we are using create, modify, and remove tables and other objects, that comes under DDL. And other objects means it's table, stored procedure, views, and indexes, lots of other things. But whenever we use create, modify, or remove tables, then that comes under DDL. So for example, create is used to create a new object or create a new table, suppose, right? So that is create is also used to create view. stored procedure, right? That is also comes under DDL. Alter is used to add a new column, suppose modify data type of new column. So alter is to alter the, yeah, modify the column details like column data type, for example. Then drop is used to remove an object, any type of object. It can be table, it can be procedure, anything. Rename is used to rename an existing object, suppose rename procedure name, rename table name. And here is one example how to create a table. Create table product id int is the data type, primary key is the constraint, name varchar2 not null, price decimal null. So this way we can create a table. This is DDL statement. You can see other DDL statements in our other SQL lecture series. We have covered all the DDL and DML commands there. So I will give a link of that particular video in description box. So DCL statements used to manage access to the objects in database by granting, denying or revoking permissions to specific users. Right? For example, if suppose I want to grant permissions to access or modify the table, one table, right? So in that case, we can use grant command. Grant is to grant the permissions. So deny is to remove the permissions, means to deny the, to just remove. One is grant, other is to deny for that particular permission. Revoke means remove a particular granted permissions, that is used for removing. So if you see below command, that is grant, select, insert, update on product to user one. So here we are granting select, insert and update commands. It means person can use these commands. User can use these commands on product table. So permission is granted. If suppose I want to deny permission, insert permission, in that case deny, insert on product to user one. Only one permission will be removed. Right? If suppose I want to remove all the granted permission, in that case revoke. Right? So these are DCL commands. Then DML commands. DML commands, its full form is data manipulation language. This is used to manipulate the rows in the tables. This helps to retrieve the data, insert new rows or modify existing rows, means do manipulation in the data. And we can also delete some rows using DML commands. So four types of things are coming. Select to extract the data or read the data. Insert means to insert new rows into the table. Update means modify data in existing rows. And then delete is to delete the existing rows. So if suppose I want to use select command normal to retrieve the data, that also comes under DML. How to use that? Select star from customer where city equals to Seattle. Wherever city is Seattle, so extract data from the customer table for all the columns. So this is one example of DML statements. Next is to retrieve only a specific subset of columns from the table. In that case, by instead of using select star, we can use select column names from customer where city equals to Seattle. If a query returns many rows, they don't necessarily appear in any specific sequence. If you want to sort the data, suppose for sorting perspective, what we need to use order by on particular column to sort the data. So in that case, select first name, last name, address, city from customer where city equals to Seattle, order by last name. Right? So here we are retrieving specific columns and ordering is done on last name. By default it does ascending order, and we can have descending order as well. In that case, order by column name, DESC for descending order. Similarly, next is joins. Suppose we need to extract data from two or more tables. In that case, need to use joins in the tables. So for join perspective, we need to extract the data from orders table from customer table on customer o.customer equals to c.id. So it should be same, right? So I if you see overall, then we are relating on the basis of customer ID and extracting data from orders as well as from customer table. So this is join. Okay, so next is coming to database objects. So relational database can contain other structures that help to optimize the data organization. So it encapsulate programming actions wherein we have two or three actions in the same, and we want to trigger that action at some interval, right? So in that case, we need to have some stored procedure, and in the stored procedure we can have some parameters, or maybe we are doing some processing and then returning it back to the calling part, right? So this is to have more optimization in the data processing part and also improve the speed of access. So few database objects are like views, stored procedures, and indexes. Okay, so next we are covering database objects. So first database object is view. So if you see, view is like a virtual table which is having contents from multiple tables, or maybe from one table, one or more tables, right? So view consists of a set of columns and rows of data from other tables, and also view can have references from the tables in the query, right? For example, suppose some perspective we need to filter the data from the table, and this data, we have very complex query to extract the data from the table. So which we can do, like based on some calculation or some kind of some sort of calculation or something, we are extracting data from a table based on some filtering, and we can keep it in a view. From two or three tables we can extract the data and keep it in a view, and then further we can use view in other things, like maybe we can use in Power BI for reporting perspective, or maybe we can use this view in procedures or somewhere else, right? So this view is basically used to simplify and customize some calculation part or some data from the tables. And that's the reason it takes data from only from the tables only, right? So we can look into this example. So for example, you can create a view on order and customer tables, and that retrieves order and customer data. So make a single object for some perspective, and we need to identify, or maybe we can have we can look into the deliveries as well, delivery addresses as well. So how we have written this query: create view deliveries as select o order, order number, o order date, c first name, c last name, c address, c city. So here we are taking data from two tables, order and customer, and just putting join on both the tables using customer id. So this way we are extracting data and clubbing data from the two tables, required data we are clubbing from the two tables and putting it into the view. Next, coming to stored procedure. Stored procedure is another database object. Stored procedure is used to have some programming logic to do some actions on some data, right? So in procedure we can pass some parameters as well. Suppose we need to identify, or maybe we can take one example. Suppose in employees table we have to calculate salaries of employees every month, so we can have that logic in procedures, right? So procedure can have some programming logic or maybe some calculation part, and that can be called from anywhere. So once we create the stored procedure, then we need to call stored procedure to execute it, right? So let's take this example. In this example, we have created procedure with name, rename product. So we are passing name of the product and product ID. So updating here in this procedure, update product set name is equals to new name, where ID equals to product ID. So product ID and name to be passed as parameters whenever we are executing this procedure. If suppose we are executing procedure from 4 different places, we can pass different product ID and different names, right? So that way we can use this procedure. And if we go next, then we can have another example, right? So when suppose product must be renamed, you can execute procedure passing the id of the product name and new name. This is same for parameter perspective, we can add here and we can modify, right? So for this exam perspective, this much information is enough for procedure. But if you want to go into detail, then we can just look into the complete series of stored procedure. So I will give details in description box so that you can go through those videos as well if required to go into detail. Okay, so next is index. So now index is another database object. So index helps you to search the data in the table. So maybe we can take some examples, like, so think about index, right? Suppose we have a book, right? In the book we have index helps us to search particular page number based on some topic name, right? So that helps us to go into that page fast, and that helps to searches fast, right? So book index contains lots of references of the pages, and then we can go there. Same here, right? So when you have to find suppose any particular data, any particular value or any particular row record based on some criteria, then we can do some that searching fast through index. right? So for example, if we are just implementing this index on particular column, right, say product id, right? So in that case, based on we can have it on product id or maybe product name. So based on that, whenever we searches based on that name or id, in that case it will fast searches or fast identify the data. So you can look into this index. This is index idx product name on product name. So index created on the name column, right? So this index creates tree based structure automatically. So how it creates, like for example, a to l references here, m to j references here. So this way it has reference where data is stored actually. So whenever we are finding data and name starts from, suppose say particular l, in that case it knows that where it has to go to search specific string, right? So in this way it's easy to search in the storage, and so in less time, or maybe fast filtering or fast extracting of the data is feasible in case we implement indexes, right? And if we have primary key on the table, then it automatically has index created on the primary key for fast searches. Okay. So so we have covered database, four database objects. If you see, table, view, procedures, and stored procedures and indexes. So four database objects we have covered, and overall we have gone through what are the SQL commands, right? What is RDBMS, and then database objects, and in SQL commands, different data SQL commands type like DCL, DML, and DDL. And so this is module 2 part 1 completed, right? So in next session we will go through module 2 part 2, wherein we will cover Azure SQL services and capabilities, then Azure services for open source database, and Azure relational database services. Hope this video is helpful for you, and please subscribe this channel so that you can get details of upcoming videos. Thank you. Thanks for watching.